No, not during math. We've made that rule from the beginning. Today we are talking about the language of subtraction. Last week we spent a lot of time thinking about addition and what that means, what that sounds like. Today we're going to be talking about subtraction. What do you already know about subtraction? I know you did subtraction in second grade, probably even somewhat in first grade. Put it up, Bryson. What do you already know about subtraction? Rylan, what's something that you know? All right, so we've got this language of takeaway. And Rylan even gave us a really good hand signal, right? I'm taking something away. We know that subtraction is taking something away. Evelyn, what else do we know about subtraction?
We know that it's got the word subtract in it.
Sure.
So,
yeah, we know that subtraction and subtract are in the same word family. Sure. Jan, what do we know about subtraction? Okay, it's not addition. There. Colby? Whoever told you that was really wrong, because that's not true. I'll give you an example, Colby. I'll give you an example. You got $13 in your bank account, but you want to buy pizza that costs $15. When you go to the store, you can run that card. It'll let you buy that pizza for $15. And guess what? You will be in debt $2. You owe that pizza company $2. But you didn't start with the biggest number, did you? Nope. A lot of you have that same thought. And unfortunately, it's kind of true in first and second grade math. Because you're not going to see problems that don't start with the biggest number. But in real life, which you guys are a part of real life, that is not true. So we need to get that out of our brain. We need to get that out of our brain. John, what do you know about subtraction?
but you want one third. I have this really good question, but is it like you could use subtraction and all the errors adding things we did? Can we use the subtraction with every one of them?
With like all those strategies?
Yeah.
Kind of. A lot of strategies will be similar. Kaden, what do you know about subtraction?
It's kind of like minus.
Yeah, we have another language piece that we've heard. We've heard the word minus. We know that the subtraction symbol looks like this. Writing, Colby.
Would that be U or
It is a U minus. So there are two ways to describe a subtraction problem. Let's go ahead and write some of these in English. So let's start with something pretty obvious. Let's start with 10 subtract 7 equals box. What is that box? We talked a lot about that last week. What is that box? Huxley. If this box hater, a number is going to go there. We've just put a box to hold its place. Now, when I translate this to English, I'm thinking about the meaning of these symbols. So, what does this symbol mean? 10. What does this symbol mean? But what does minus mean?
take away?
Let's use some English that we do now. take away. I can picture that. And that's what we're writing, baby. I've got 10 things, and I'm taking away. What does this symbol mean? 7. What does this symbol mean? We spent a lot of time talking about that last week. What does that equal sign mean? Ariana? Is the same value as what does this symbol mean? Zach? Spot saver. Mystery number. Dots. When I look at that equation, I want to be able to read those words because those words have meaning. I know what it means to take something away. I know what it means that something has the same value as something else. So we have translated our equation into English. All of your math career so far, this is what you have been told is subtraction. Yes? It's not wrong. It's just not the whole picture. There is another way to think about subtraction. And I'm a little bummed that you guys didn't learn it in 2nd grade, but don't worry. I'm here. You're welcome. I'll catch you up. Have you ever heard of the answer of a subtraction problem, this part right here? Does anyone know what that's called in math? Right, we call the answer to an addition problem the sum. Does anyone know what it's called the answer to a subtraction problem? Gia, do you know? You gotta do your thinking before you raise your hand, baby. Heidi, you know?
The total?
Not the total, no. Kaden?
Sum?
Nope, that's for addition. Kobe? Nope. So, the answer to a subtraction problem is called the difference. Probably have heard that before. Now, you're probably wondering, why is it called difference? Right? The word different seems like different. Things are different. Jalen, get out your desk, please. We're going to talk about the other way to think about subtraction, and it has to do with that word difference. To help us, we're going to look at a number line. If you've got more space, you can keep writing on that page. We're just going to look at a number line to help us figure out what's really happening here. You do not need to write any of that. You just need a number line. Just a number line. We're going to work with that same equation that we just wrote down and translated into English. Now we're trying to figure out this word difference, right? Earlier, we talked about subtraction being takeaway. And we've done some subtraction on a number line. We know that we're going to start at the end. I'm going to put my 10 down here. I'm writing, that means you're writing. And then I'm going to take away 7. Count backwards with me. Ready? 9. Alright. I've done 1, 2, 3, 4, 5, 6, 7. I counted back 7. And I ended at 3. 10 take away 7 is 3. So far, so good? This matches what we know. We're going to do it a different way now. Draw another number line. You're still going to put 10 on that number line, because we're still dealing with 10. But now we're going to talk about that word difference. This equation really wants to know what is the difference between 7 and 10? Or what is the distance in between the number 7 to the number 10? So let's put 7 on our number line. It's going to be here-ish. Right? So far, so good? All right, well, let's count and see how many numbers are in between 7 and 10. Ready? 8, 9, 10. How many numbers are in between 7 and 10? Carl? 3. Weird. There are 3 numbers. Macklin? Not always. So another piece of English. Actually, let's go ahead and write this on the next page. Turn to the next blank page. At the top, we're going to put our same equation. We're just going to think about it a little differently. Instead of starting with that first symbol of 10, we're going to talk about what we're doing. I can already see that subtraction symbol, which tells me I'm finding the distance between, or the difference. So I'm going to write the distance between right? The distance between what 2 numbers? Tells us right in the equation. Carl, what are the 2 numbers that we're trying to find the distance between? Nope. Look in our equation. No, you shouldn't have to turn the page. You already wrote it down. Right at the top of your page. There should be.
Oh, the distance between.
Yeah, the distance between what? What 2 numbers?
10
10 and 7. There you go. Distance between 10 and 7. Now I got my equal sign. Is worth spot saver. The distance between those words came from that subtraction symbol. That's what that symbol tells me, is I'm looking for the distance in between those 2 numbers. So far, so good? So let's think about this. When would I want to use each one? Well, let's say that I had a really big number. 425 cupcakes. And I needed to give one to everyone in this class. We don't have 425 students. But could I just count back the 18 kids that I do have? Would that be super crazy? No. But what if I had 425 cupcakes and I was taking away 423 of them? Would it make sense to count backwards 423 times? No. You're just going to look at the difference in between those 2 numbers. What's the distance in between 423 and 425? It's just 2. Does that make sense? We kind of change how we think about subtraction depending on what is easier for our brain. You could do either or. If you wanted to count back 423, You could do that. It just take a long time. Alright. So, next blank page, here's our title. Right now we're just going to focus on a strategy that you've done and used. Subtraction as takeaway, thinking about it as takeaway, aka counting backwards.
Is that like the number line?
Yes, this is like the number line. Macklin?
I know the way about the reason. You just take away the 7 and you know what's completed. But so you just want to see, you know how to, because 7 and 10 are different numbers. So one that maybe is the same number as 7.
Yeah. When I'm subtracting and I'm taking something away, I'm not going to get more of it. If I have 18 pencils and I'm giving some to different students, am I going to have more than 18 pencils? Huh?
You're going to have 0.
Yeah, I'm going to have less pencils. I might have the exact same if I don't give anybody anything, but I'm not going to get any more pencils. So when I'm doing that on a number line, I'm going to start on the other end of my number line. Because I know when I'm on my number line, I'm not going to be going forward. I'm not getting any more things. I'm going to be going backwards. I'm giving stuff away. So far, so good. Then I will go this way. Not while I'm teaching. Anyone? A couple of you still writing? When I went back 100, Tegan, now what number am I on? 245. Beautiful. Macklin, I'm writing. What should I do next, Madison? You want to do a 10? Okay. What number am I at now? I'm at what number? 235, yeah. Now what? Let's see. Nope, I'm going backwards 234. I'm not going to jump to my ones yet. I have lots more I can jump backwards from. I'm not trying to get to the number 235. I'm trying to count backwards 234. So I need my jumps to equal 234. Does that make sense? So far I've only jumped backwards 110. Okay. If I go back another 10, what number am I at now? 220. Ooh, forgot how to write a 5 for a second. 5. Now what? Caleb? I would do another 100. We still got 200s. I might as well do another 100. Jalen, when I did that, now what number am I on? 125. So far, so good? Let's count how far back I've gone. Ready?
100, 110, 120, 220.
I've gone 220, but I need to go 234. Now what? Okay then? Another 10? What number am I at now, Kaden?
115.
I've gone 200 jumps. I've gone 310 jumps. Now what? Chloe? Just one? 4 ones. What number do I land on when I go back? 4 ones. Mackenzie? 111. So when I start at 345 and I go backwards 234, where do I end up? Where do I end up? Evelyn? 111. This strategy hopefully is not new. Counting backwards on a number line should be fairly familiar. Okay? We also started looking at word problems. Let's check out a word problem and see if we can work through it. Now, I'm going to give you a word problem, but there's no numbers in it. And the reason I do that is because I want you to think about what's happening in the story. You ready? There are some third graders. There are fewer second graders than third graders. How many second graders are there? What are you wondering? Kaden, what are you wondering? How many third graders are there? That would be good information to know. What else are you wondering? Gio, what are you wondering? That would also be really good information to know. How many second graders are there? Evelyn, what are you wondering? Are there more third graders or more second graders? John, sit up. Are there more third graders or more second graders? Huxley? How do you know there's no numbers? That word fewer meaning less. So even though we don't know how many, we know there's more third graders. Fair? Yes. So in this problem, Colby, great question. He said, can I make an equation? Yes. Do I have any numbers? They would all be unknown numbers. They would all be spot savers. Because I know that if I need to figure out how many fewer, I need to start with what? What number do I need to start with? Yeah, I don't know. Spot saver, and then another spot saver, and another spot saver. Let me give you some more information. You ready? There are 166 third graders. There are fewer second graders than third graders. How many second graders are there? What could be an amount of second graders? Based on this problem, what could be the number of second graders? Bryson? 165. It could be 165. Bryson, how do you know that? Yeah, beautiful. 165 is fewer. It could be 165. What else could it be? Evelyn. Could be 1. Likely not 1 because it's plural, second graders. But it could be something really little like that, sure. Kaden? 2. That would be plural. Tegan? I'm going to give you a few more pieces of information. There are 166 third graders. There are 19 fewer second graders than third graders. Does that mean there are 19 second graders?
No.
No, that is not what that says. How many second graders are there? What are we counting in this problem? We've read it a lot of times. We need to figure out what we're counting. What am I counting? It tells me in the problem. I just gotta tell me. What is the thing I'm counting? Am I counting puppies? Nope, not counting puppies. Mappa? Mappa?
Second graders and third graders.
I'm not counting second graders and third graders. Look very closely at our question. What am I counting? Just counting second graders. Who can put it in an answer sentence? Who can put it in an answer sentence? I am counting second graders. Go for it, Jalen.
There are 19 less second graders than.
Okay, well, where's my answer going to go? That's an answer sentence. I need a spot for my answer. Ariana? The question says, how many second graders are there? What's going to be the answer to that? Flip it. How many second graders are there? Evelyn? There are blank second graders. We're writing. We didn't create that sentence for magic. It came from the question. It says, how many second graders are there? The answer is, there are blank second graders. I know an answer is going to go in that blank. I just don't know what it is yet. Okay? Okay, I'm not ready for the answer. That is like step number 5. We're on step number 2. What is the next thing that I do? If you don't know, it's on the wall. If you don't know, it's in your notebook. It is not in your notebook, but you could have watched the lesson, and it's also on the wall. So sitting there doing nothing is not solving your problem. Macklin? No, absolutely not. Mackenzie?
Make a model.
Make a model. We need to draw what's happening. Carl, read that first sentence to me.
There are 166 third graders.
Pause. Am I drawing 166 sick people?
No.
No, absolutely not. But I can draw a box. Ooh, that was a little much. Here's my box. That box is going to represent all my third graders. So far, so good? Bryson, how many third graders were there? I'm going to pop that in there. That box is worth 166. Now, I'm going to draw another bar of second graders. Is that bar going to be longer or shorter than my third grade bar? Why? Right on, why? less second graders. So I'm going to start my bar almost at the same spot, but I'm going to make it a little bit shorter. This is my second grade bar. So far, so good? Yes. Now this is where it gets a little tricky. So listen to the words I'm saying. How many more kids would I need until I had the exact same number? I have less second graders. But how many more would I need if I wanted to have the exact same number? Bryson? 19. Yes. I need 19 more second graders, and then they'd be equal. Because right now, it's fewer by 19. Does that make sense? Yes. Rylan, you with me? So this ghost box is 19. Those kids don't actually exist. The 19 ghost kids. They don't actually exist. But Bryson and I know that if they were there, third grade and second grade would have the exact same number. Does that make sense? I don't know. So right now, I'm going to put a question mark in this box. Why did I put a question mark there? And it's not because I like question marks. Huxley? I don't know what. What specifically do I not know? Nope, that's not what I don't know. What do I not know? It's got nothing to do with the word answer. What is this problem talking about? What does that box mean? Kaden, what does that box mean?
How many second graders?
I don't know how many second graders. So it's question mark. Could it be smiley face?
Yeah.
Yes, it could. Could it be triangle?
Yes.
All spot faders. Number is going to go there. We just don't know yet. Hey, that looks like something I know. That looks like a part whole. Can you see it?
Yes. No. Yeah.
Let's label. Here's my whole. Do you see that? And then my part. And then my other part. This is where bar model is really cool. Because now I can make a whole bunch of equations. We learned how to add last week using part whole. When I'm adding, do I start with a part or do I start with the whole or the total? When I'm adding stuff up, do I start with a part or do I start with the total? Colby? No, it's not either or. Do I start with a part or do I start with the total? I start with a part. Which part you want to add with? The real number? All right, 19 plus. I'm going to add my other part, Zach. What is my other part? Yeah, you.
It's
I'm not looking for you to do any math. I'm looking for you to look at what I've written down. The other part is question mark. I'm going to put a box. It's a spot saver. And that gives me a total of, what is the total? Tells me right on the board. Carl, 166. Heidi, I'm writing. That means you should be writing. I made up that equation straight from my bar model. When I subtract I start with the total. Always. When I subtract, I start with the total. Always. When I subtract, I start with when?
Now subtracting.
Always. What's the total? Or the whole? It tells me right on the board and right in your notebook. I don't have to think about any of this. Right, so what's the total? 166. I'm going to take away one of my parts. Which part would you like to take away? Heidi?
No question.
Whole minus a part means that I'm left with my other part. If I start with my total and I take away this section, all I have left is my other part. So far, so good?
Yes.
I'm really bad at subtracting boxes. Are you good at subtracting boxes? No, me neither. I'm going to make up another equation. Starting with the whole. But this time I'm going to subtract my other part. What is that other part? It's written on the board. Mackenzie? 19. And then I know that I'll be left with that other part, which is my mystery number. Nope. You just made 3 equations from that bar model. This is the hardest part. Anyone can subtract. A calculator can do it. Calculator can't create equations, though. Only you can. These are the types of questions that will be on the EOG. It is not going to be what's the answer. It's going to be what's the equation. A calculator can find the answer. We got to figure out which equation. Now, Heidi, you told me you're really bad at subtracting boxes, right? Yeah, me too. I'm not going to pick this one. That seems really hard. It's accurate. It's true. But it's not making my brain happy. This one's making my brain happy. Because I can do 166, take away 19. So far, so good. Number 9. What's going to go on the end of my number line? First part, you raise your hand. That? 166. And we are counting backwards. 19. What do you want your first jump to be? Yep. 10. Love it. Where are we at now? Yep. 156. Oops, that's not a 6, that's a 9. Come on, brain. Now what? Tatum? Or what? 5. Where am I at now? Yeah. 151. Now what? Okay, B? Nope, because I'm starting at 151. So we'll go backwards one. 148. Right? 50, 49, oh, 48, 47. All those spot savers. What goes in them? Again? 147. Sure. You know the number now. How many second graders are there? I think 147. John, what's up, baby?
I already noticed the subtractive box.